When I was really young, I walked into a cafe for the first time. I never drank coffee up to that point, and I wanted to start. But I didn't know what any of these drinks meant. Late, latte, mocha. I thought to myself, since all of them will probably taste the same anyway, I wouldn't be able to tell the difference. Let's go for the cheapest one. The least expensive option. And I went for espresso. Espresso.
Espresso.
Some of you are probably already groaning, and those of you who don't worry. We will find out soon enough. My order arrived and it came in this tiny cup. I thought someone made a mistake. Does espresso mean coffee for babies? So not knowing anything, I just went in and took a big gulp of it. I'm not sure how to describe the feeling. Remember, I'm not a coffee drinker, and I chugged that one down like water. It was bitter, of course. It was strong. It was... yeah. I felt a jolt. Pika! So I was asking myself, why did they not dilute this? It's so concentrated. It's too pekat. It's too cow. Just add water or milk or anything. Turns out, that is how coffee is made.
Courtesy of Yuzubakes.com, we have a coffee guide. We will start out with espresso. Add milk to the espresso and you get cappuccino. You want more? Here's your latte. Less milk, more chocolate? Mocha. Oh, you just want hot water with your espresso? Americano it is.
After that, I swore off coffee. But I wonder how life would have changed if I decided to order Americano instead of espresso. Anything other than espresso. Similarly, in chemistry, you have to use standard solution for experiments. Standard solution is like the Americano. It has a lower molarity. We start out with the stock solution though, the espresso. We have to take a small amount of it and then dilute them with distilled water. Your calculations have to be very precise, and that is the goal for this video today. So yes, the first 2 minutes of this video is wholly unnecessary, but so is YouTube. And plus, I read about coffee for around 5 minutes. That makes me a coffee expert, and I've got to show it off. Here's a sample question. You've got a stock solution of 2 mol per decimeter cube, and your goal is to prepare a standard solution 100 centimeter cube with a molarity of 0.5 mol per decimeter cube. Whatever this substance is, you need to know how many moles do you need in the standard solution. We will calculate that using mv per 1000.
Slot in the molarity and volume, we'll get the answer 0.05 mole.
Now we've got the answer. This is the number of moles we need from the stock solution, and we have to calculate it with mv over 1000 as well. But this time, we know the number of moles, we know the molarity, we need to find the volume. There is an easier way to do this. That will be m1v1 equals to m2v2. Okay, place in the values and you will get the same exact answer. The answer is 25 centimeter cube of stock solution. So we will collect this amount of stock solution and we add in exactly 75 centimeter cube of distilled water. Now why? Because our target is to get 100 centimeter cube of a solution with this molarity. Let's try it out with another example, shall we? This time we have a stock solution with a molarity of 5 mol per decimeter cube. And our standard solution, 0.4 mol per decimeter cube, 250 centimeter cube. We'll do it the long way again. That's by finding the number of moles we want in the standard solution. We can then calculate the volume of stock solution that we need to dilute.
This time, try it out with the M1v1 M2v2 method. Good luck! Here's the working and the final answer.
So that's it for now. If you have any other questions, including about coffee, because I'm an expert now, go ahead and ask in class. Until then, see you!
Yeah!